Hello, class. Today we're going to be talking about two special types of right triangles. Well, there are two special types of right triangles. Go figure. That show up a lot on standardized tests. We're talking mainly about the SAT. Okay, it's a big focus here. Okay. So we've seen these on the cheat sheet they provide. Okay, you've seen these before on the cheat sheet we've gone over in class. The first one that we're going to talk about is a 30, 60, 90 right triangle. It says that. It's called that because one angle is 30 degrees, another one is 60 degrees, and the third one is that 90-degree angle that makes it a right triangle. The other one is a 45, 45, 90 right triangle. Here you've got two 45-degree angles here, and then the 90-degree right angle in there. Okay, so those are the two types we're talking about. And really what we're talking about is the ratio between these sides. Okay, you see here you've got x, 2x, and x square root of 3. That simply means that when you have this kind of triangle, these sides are always going to be in this proportion. This first side is going to be x. This is twice the length of this side. Remember that twice length is always opposite the 90-degree angle. And this side opposite the 60-degree angle is going to be this length times the square root of 3. Okay? And the 45, 45, 90, if you call this S, okay, or if you know one of these two legs coming off the right angle, well, then the hypotenuse is going to be this times the square root of 2 every single time. We're going to take a look at a little bit more about what that means. Okay, this is great information to have, but how do you use it? Okay, and that's what we're going to talk about here. Essentially, the sides of these triangles are in a specific proportion or ratio to each other. Okay? If you know you have one of these triangles and you know one side, you can solve for the other two sides in a triangle quite easily. So, first example, we have a 45, 45, 90 triangle. Okay, 45, this is 90. Well, you know, some of the internal angles of triangles are 180, so if this is 90 and that's 45, you know, this is 45. Okay, it gives us here this length of 4. Well, we saw above that these are in the ratio of S, S, S times the square root of 2. Well, that says that S equals 4. Okay, you're reading that right here. Okay, one of the legs is 4. Well, if S is 4, that means W down here, W is going to be the same length as S, and that's also going to be equal to 4. So far, so good. Y then is going to be, Y is going to be S times the square root of 2, which is going to be 4 times the square root of 2. That's the exact answer. If you put that into a calculator, that's going to give you something about 5.66. Okay, so that would be the length of this side here, 5.66. It's a little bit more than either of the two lengths, which makes sense because it's opposite the 90-degree angle, making it the hypotenuse. Let's take a look at another example. Okay, so here we have a 45, 45, 90 triangle again, but this time we don't have either of the legs, but we do have the hypotenuse. Okay, remember, these are in the proportion S, S, S root 2. Okay, so let's take a look at this. So we know that S root 2 equals 7. We have that. So if I want to figure out what S is, I'm simply going to divide both sides here by the square root of 2. Divide this by the square root of 2. Divide this by the square root of 2. So I get S equals 7 divided by the square root of 2. Now, I got to tell you, if you're working in delta math, it's not going to like that. Okay, it's not going to like that at all. Mathematically, you never want to have a square root in your denominator. You're going to do something called rationalizing the denominator. It's a really fancy term that means we're simply going to get rid of the square roots here. So to do that, it's very simple. We're going to go ahead and multiply the numerator and the denominator by the square root of 2. Okay, remember, anytime I've got the same thing in the numerator and denominator, that is simply a fancy way of saying 1. Okay, when I do that, that equals 7 times the square root of 2. Square root of 2 times the square root of 2 is simply going to be the square root of 4. Hey, we know what the square root of 4 is. That is going to be 2. So that leaves me with 2 in the denominator, and I end up with 7 square root 2 right there in the numerator. Okay? So if you're in delta math, you're going to want to put it in like this. It'll give you a symbol for the square root. It'd be 7 square root 2 over 2. When you get to Moodle, okay, and you want to get just a number versus this fraction, you're going to go ahead and put that into a calculator. You go 7 times the square root of 2 divided by 2, and that's going to give you something right around 4.9497. Okay, so that would be your answer if you put that into the calculator for putting it into Moodle, things like that. Okay, let's take a look at one more example. Okay, actually two more examples. Now we're going to get into the 30, 60, 90 triangles. Okay, my 30, 60, 90 triangles. Remember, here we have a different ratio. We have the ratio here of x. Okay, this is going to be 2x, and this is going to be x times the square root of 3. Okay, those are the ratios that those sides are in. Okay, if this is x, this is going to be twice that length, and this is going to be that length times the square root of 3. Okay, so looking at this, well, we can see that x times the square root of 3 equals 5 square root of 3 in this problem. I divide both sides by the square root of 3. Okay, those cancel, x equals 5. Okay, so w, this side here, w is going to equal x. So in that case, that equals 5. So this length here is 5. Y is going to equal 2x. That's going to be 2 times 5. So that's going to equal 10. Okay, so this side here equals 10. That one's pretty straightforward. They gave us that as the square root of 3 and everything, so that makes everything real nice and simple. Now, coming down here to our last example. Okay, I'm going to scroll down here so we've got plenty of room. Okay, looking at our last example here. Again, I've got a 30, 60, 90 triangle. 30, 60, 90. I've got x. I've got 5. Okay, I'm not going to call that x. I'm going to call it something else because I know in a 30, 60, 90, typically we call this x. We say this is 2x. And this is going to be x times the square root of 3. Okay, so we know right here, x times the square root of 3 equals 5. Okay, so I'm going to divide both sides here by the square root of 3. Okay, when I do that, those cancel out. So x equals 5 over the square root of 3. Again, we don't want to leave a square root in the denominator, so I'm going to multiply that by the square root of 3 over the square root of 3. Again, that's just like multiplying by 1. So that gives me 5 times the square root of 3 over the square root of 9. Okay, 3 times 3 is 9. We stay in the square root. Square root of 9 is pretty straightforward. That gives us 5. Square root 3. Square root of 9 is going to be 3. Yay! So we got our x. So that tells us that this side right here is 5 square root 3 over 3. And this side here, 2x, is simply going to be 2 times 5 square root 3 over 3 equals 10 root 3 over 3. Okay, and again, these are going to be the values that you plug in Delta Math. When you get to Moodle, go ahead and use your calculator to get the numeric representation. So this would be 5 times the square root of 3 divided by 3, 10 times the square root of 3 divided by 3. Okay, not too bad. Given one side and these special right triangles, you can solve for the other two, and that's a pretty good deal. So the secret word for this video is going to be cheese, C-H-E-E-S-E, cheese. Hope that was helpful. Thank you. Bye-bye.